I have got the best Tablesaw Tenon Jig in the world. And if that sounds arrogant, well, it's perfectly possible to be both arrogant and right at the same time. And anyway, somebody somewhere's got to have the best jig in the world, and it might as well be me. The ultimate Tablesaw Tenon Jig cuts ordinary tenons, such as a rail, into a leg. It cuts tenons for face frames, which end up perfectly flush, so there is no planing at all required to make it all flat. It cuts both halves of a bridle joint, and it cuts angled tenons too. It even cuts the normally very challenging double tenon, which is incredibly strong and very beautiful. The ultimate Tablesaw Tenon Jig is robust and it's accurate. It is quick to set up. It is quick in operation. It is versatile. I can do a lot more than just tenons, and it's fully guarded. And I'm not aware of any other jig in the world that can satisfy all those criteria. Behold, the ultimate Tablesaw Tenon Jig. Welcome to Workshop Essentials. This is quite a long film because there's a lot of detail and a lot of things to talk about, but none of this is intrinsically difficult. So I suggest you settle down with a brew and a plate of your favourite cookies. About 20 years ago, I was looking for a tenon jig. I was doing a lot more woodwork then than I do now, but my hand skills were never very well developed because I've never been able to see very well what I'm actually doing, which is why I build so many jigs. I tried several jigs. I built probably 4 or 5 jigs, and I was unhappy with all of them. They were either difficult to set up, they was usually very time consuming to set up, and some of them were time consuming to actually use as well. So if you just wanted to do one tenon, it was a real pain. I remember throwing one across the workshop and using a very naughty word and thinking, I can do better than this myself. And so I made a prototype for this idea, and then I built it and I sold it as a DVD in 2008. And I'm pleased to say that it went down very well. But that was quite a long time ago. The original jig was made out of MDF, and that was fine for a long time. But when I lost my workshop, all my stuff went into storage in a barn and it got damp. And it didn't work as nicely after that, it didn't slide as well as it should. And then one day I was using it and I set it up incorrectly and ran it into the blade, which didn't do the blade any favours either because it hit a nut. That was very embarrassing. And now it lives in a barn, and although this looks very quaint and cute and country-ish, it's actually not a very good working environment. It's very damp. And so my cast iron stuff is going rusty, and it's a constant battle to keep the rust at bay. And some of the MDF stuff is going mouldy. So I'm rebuilding it, and instead of using MDF, I'm using this material. It's called HPL, High Pressure Laminate. And this modest sized piece feels heavy in the hand. It's got a relative density of 1.6 times the density of water. And if it looks like a toilet cubicle door, it's because I was working next door to a school, and they were having some refurb work done, and there was a piece of this, about a square metre, in the skip. So I asked if I could have it, and it's been waiting for something to do with it ever since. About 10 years I've had it. The weight is a disadvantage because this jig weighs a ton, but everything else about this is excellent as a material for making jigs. It is hard, it is slick, it's not affected by moisture, and it stays flat. There's no warping or anything like that. So it's a really good material. It doesn't machine well with high-speed steel tools, as you'll see later on. But with tungsten carbide, it works, it machines very nicely. The jig works by using a spacer for whichever size of tenon that I want to make. And I've got 4 chisels for my hollow chisel mortiser, and so I've got 4 spacers: 1/4, 3/8 of an inch, 1/2 inch, 5/8. And if my spacers fit the mortise nicely, then the tenon will fit the mortise nicely, because the tenon comes out exactly the same size as the spacer. This means you can use the jig to make any size tenon that you want. You just need a spacer of the right size. And the jig slides, the workpiece is here, the jig slides from one side of the blade to the other. So one cut is made with the jig closed, and then I open the jig and I put in the appropriate spacer. And that moves the workpiece over by the size of the spacer plus the size of the curve of the blade, because the jig compensates for the blade automatically. I never have to worry about it. There are 3 layers to this jig. The bottom layer rides on the fence, and then the middle layer slides over that by a small amount, and I can regulate that with this Bristol lever here. That allows me to put the tenon very precisely in the right place within the thickness of the workpiece. So if I'm making a face frame, for example, where the position of the tenon is critical, I don't want a little step that I've got to plane away. I want it to be perfectly flush. And this fine adjuster allows me to do that. And then the top layer, that's what carries the workpiece, and that slides from one side to the other. The nice sliding action is facilitated by 2 pairs of diamond keys. Now, if you've ever seen any of my previous jigs, you'll know that I use this principle a lot. It's a good engineering principle to have diamond keys which align the 2 pieces. So there's 1 pair between the bottom layer and the middle layer. There's another pair between the middle layer and the top. I have actually offset them. I figured if I was going in from both sides, it might weaken the substrate a bit, but in fact, this stuff is so strong, so hard, they could have been exactly opposite each other and it wouldn't have mattered one bit. And I wish I'd done that actually, because it would have prevented me from making 1 or 2 silly errors in the build. Nothing terminal, but... So that's the structure of the jig. And so we're going to start by cutting up some HPL and machining the grooves, the V grooves, for those diamond keys.